Hey guys, today we're going to be going over the properties of quadrilaterals and triangles. So, for number one, it says Ashley correctly draws this Venn diagram to show the relationship between quadrilaterals, parallelograms, rectangles, and squares. Okay, so if you look at the Venn diagram, okay, everything that's inside of another represents all the ones that are above it, okay? So if you look at the Venn diagram, a quadrilateral, okay, is all of the ones below. Now, a parallelogram can be a quadrilateral, okay? Same thing. A rectangle can be a parallelogram. A square can be a rectangle, can be a parallelogram, can be a quadrilateral. So because one is inside another, that means it intakes all of the properties that the other ones have as well. So keeping that in mind, Ashley knows that every rectangle has two pairs. So we're looking for two pairs of parallel sides. Now remember, parallel means that they never intersect, okay? So they're like straight across and they never intersect. And then it says, according to the diagram, which of these statements must also be true? So it says every quadrilateral has two pair of parallel sides, okay? Well, this is actually false because a trapezoid only has one pair of parallel sides. Oops. Then letter B, it says every square has two pairs of parallel sides. That is true. Okay. Letter C, every parallelogram has all of the attributes of a square. So this is actually false also because a square can be a parallelogram, but a parallelogram cannot be a square. So this is false. And then it says a parallelogram can never have four congruent sides. And that's also false because a rhombus has four congruent sides and it's also considered a parallelogram. So the only one that is true is B. Okay, number two. Based on the Venn diagram, which of the following is, this time we're looking for the one that's not true. Okay, so a square is a special type of rectangle. Okay, that is true. A rectangle is a special type of parallelogram. That is also true. A parallelogram is a special type of quadrilateral. That is also true. And a quadrilateral is a special type of rectangle. And this one is the one that is false. So J is your answer. Number three, Kevin created this hierarchy of classified triangles according to their attributes. Which of the following is not true? So we're looking again for the one that's false. Okay. So letter A, an acute triangle can also be isosceles triangle. All right, so if you look here, acute, it actually points down to the isosceles. So this is true. Okay. Letter B, a right triangle can also be an equilateral triangle. So if you look at the right here, it does not point to equilateral. It only points to scalene and it only points to isosceles. So this one is false. Letter C, an obtuse triangle can also be scalene. So if you look at obtuse, it points to scalene, so that's true. An isosceles triangle can also be a right. So if you look at isosceles right here, okay, oh, I'm sorry, over here, it's underneath the right triangle. So right triangle is isosceles, so that is also true. So the only one that is false is letter B. And the last question. Kelvin finds a tile shaped like a triangle. He uses a ruler and a protractor to discover that all sides are congruent and all angles are congruent, okay? So congruent means equal, okay? So what is the correct name for this triangle? So if I draw a perfect triangle and all the sides are equal and all the angles are equal, then that means it's a equilateral. And that's it.